Guys, let's do this question, and I read the question first. A mechanical system is described by the differential equation, that's the differential equation. Use Laplace transform to determine the function xt given that x0, that is initial condition, equals to 0, and for x prime, initial condition equals to 1. And so therefore, guys, I have already done some things here, whereby, guys, I have presented the equation in terms of Laplace transform. This is how you write the Laplace transform for the second order differentiation. And for 9x, we write like that. And the Laplace transform of sine t is given by 2 over s squared plus 4. Guys, by the way, you can check this one in mathematical tables and you shall find it. That is a Laplace transform tables. So guys, from there we are going to do the question. So what, guys, I'm going to do, I'm going now to factor out Laplace transform of x. Here we have another Laplace transform of x. But guys, before I do that, let me replace my conditions. So we are going to have s0 Laplace transform of x minus, we have s here, and now we replace our first condition, which is 0. So when we put 0 there, guys, 0 here, guys, this is now going to be 0. This is 0 minus, we can replace that, which is now 1. For the first derivative, we have 1 there, plus 9 Laplace transform of x. This one now we get finally 2 all over s squared plus 4, like that. Guys, we continue. We can now factor out Laplace transform of x. And so therefore we shall get Laplace transform of x. Let's write it here. And then we have s squared plus 9, like that. So guys, we have factored out Laplace transform of x, because you can find it here and you'll find it here. Then you have minus 1 here, and this one now gives us 2 all over s squared plus 4. From there, guys, we can now bring our one this other side. Then we shall have s squared plus 9 Laplace transform of x. This is equals now to 2 all over s squared plus 4, plus this side, this time is now going to be plus 1. So guys, we do that. So in doing that, we can put everything at the same denominator. By so doing, guys, we are going to multiply s squared plus 4 multiplied by 1. So we shall get 2 plus s squared plus 4, like that. So all over, this is under s squared plus 4. And on this other side, guys, we have s squared. I can even put Laplace transform of x first, and then I put s squared plus 9, like that. By so doing, guys, I can now put this s squared plus 9 on this side, that is at the denominator. So guys, we have Laplace transform of x there is equals to 2 plus 4 is 6, so this is going to be s squared plus 6 all over s squared plus 4, like that. Then we can put this one here, s squared plus 9, like that. So after we have put there, guys, we can come and look for us to be able to get s, we are going to look for inverse Laplace transform on that side, and inverse Laplace transform of that side. So guys, we are going to get this side, we will get x, and this other side, guys, we'll have the inverse Laplace transform of a squared plus 6 all over a squared plus 4 a squared plus 9, like that. So after that, guys, we are now going to look for Laplace, inverse Laplace transform of x. And so guys, I believe that guys, I hope and I believe that you can remember this. This is what we did in one of our videos, and we were finding the Laplace, the inverse Laplace transform of that. And so guys, you can see it's still the same thing we are going to look for. And so I could refer to you to my last video. But for the sake of those who are new, let me show you what I did, guys. This is what we did. Guys, I did like this. This is where we started the problem. And guys, I was able to divide into partial fractions first. That is before I did inverse Laplace transform. And after that, guys, I was able to find my unknowns. That is A, B, C, and D. And we found that A and C was actually 0. So guys, finally we were able to find B, we were able to find D, and guys, this is what we found as our partial fractions for that. We got that and that. And guys, now we were able now to find even our x, which is now supposed to be like that. And so guys, this is actually our solution. And guys, I can write it even in the paper that we have here, so that now guys, we have, after we have done this, guys, we shall get, I can write x, this is now going to be equal to x inverse Laplace transform of 2 over 5, I write inverse there, all over a squared plus 4, like that, plus inverse Laplace transform of 3 all over 5 a squared plus 9, like that. Guys, when we come at this point, you need to remember, guys, you need to remember that we usually have that sign 80, that is inverse Laplace transform of that, not inverse, but the Laplace transform of sin 80 is given by A all over, that is, I can draw Laplace transform there, is given by a squared plus a squared. And so guys, our solution then is going to be x equals to, for this it means the inverse of that, guys, will give us that. And so guys, we come and check this equation. As you can see, we have here, just like we have a, and here it is a squared, the same we have 2, and this is now 2 squared. So guys, we shall have 1 over 5, like that, because already 2 is supposed to be here together with a squared plus 4. So 1 over 5 sine, this is now going to be 2t, plus, the same happens to this, guys. This 3 and 9 are together. So 1 over 5 can be factored out. Just like we have done here, we factor out 1 over 5. We are left with 2 there, so that we can fulfill the condition of this equation. So this is going now to be sine 3t. Guys, this is now our solution. And thank you for listening to me. Bye bye.